Continuing in example 1, we're going to use the standard ABC format for the right triangle. So I know B and C. It helps to make a quick picture of this. Okay, so I have my right triangle, which is angle C. I know side C is 450 across from it, and angle B, if I label these as A and B, and I know 100 is side B across from angle B. Okay, now I can use the Pythagorean Theorem to find the third side. I don't know what my angles yet, but I can find that third side right away. So little a squared plus 100, that's B squared, equals 450 squared. Okay, so little a squared plus 100 squared, which should have 4 zeros, so 10,000, equals, if I square 450, I get 202,500. If I subtract off the 100 squared, or the 10,000, that gets me 192,500. Now I take the square root of both sides. So A equals, I'm not writing the plus and minus here because I can't have a negative side length in the first quadrant. I'll write it just in case, but we're going to use the positive. So it's 192,500. Alright, I need to separate that and to get it simplified. The first thing I know is you can certainly divide it by 100, which is a perfect square, but let's see if you can divide it by anything more. Yeah, it looks like 2,500 goes into it, and 2,500 will have a perfect square root of 50. So I'm going to separate that into the square root of 2,500 and 77. Again, on my calculator, to figure out that this was going to work, I knew I could divide it by 100, and then I checked the remainder to see if I could divide it by 25. That meant that 2,500 went into it 77 times, and then the square root of 2,500 is again 50. So now I'm going to be able to write this as A equals 50 times the square root of 77. Okay, that's length A. 50 times the square root of 77. Alright, so now I need angles A and B. We're going to use two ratios to find them. Okay, now let's go ahead and find angle B first. I already know that I have given to me an opposite and a hypotenuse for B, so that would be sine. So sine of B is equal to the ratio of 100 over 450. Now that's not one of my pretty ratios. Even if I reduce it, I'm not going to get something like a half or square root of 2 over 2. So I'm going to use the arc sine. So B is equal to the arc sine. If you want to reduce that, you can. It's not actually necessary, so I'm just going to leave it alone, of 100 over 450. So I can use my calculator or Desmos. Just want to make sure that Desmos is in degree mode before I use it. And I can type in arc sine of 100 divided by 450, and it gives me the approximate angle that goes along with it. So that approximate angle for B is 12.8396 degrees. Okay, so 12.8396 degrees is our B. Now I need to find angle A. Okay, we're going to look at this two ways. First, the easiest way is subtracting from 90. So A is going to be 90 minus 12.8396. Okay, so if I take 90 minus 12.8396, that gives me a measure for A of 77.1604 degrees. So I now know angle A and angle B, so the triangle is solved. Now I could find angle A a different way. Let's talk about that just to confirm. In terms of angle A, 100 is the adjacent, 450 is the opposite, so I could use cosine. So cosine of A is equal to 100 divided by 450. So A should be equal to the arc cosine of 100 divided by 450. And just to confirm, let's check that we also get the 77.16. If I try the arc cosine of that same ratio, 100 over 450, 77.1604 looks perfect. Okay, so we can find that angle in two different ways. I recommend, of course, the subtraction as the easier method, but just helpful to know that I could have done it either way. There are many other ways I could have used. Once I knew this ratio, I could have found angle A from the, say, arc tangent of 50 square root of 77 over 450 as well. Lots and lots of methods I could have used, trying to stick with using the original value as much as possible in case we had made a mistake in one of those values. You don't want the mistake to be replicated throughout. Alright, let's take a look at the last triangle. I have an angle. Ooh, it's in degrees and minutes. Fascinating. So I want to find the next one in the same notation. So we're going to, for angle H, take 90 degrees minus 28 degrees, 34 minutes. I'm going to do this on my calculator so that I don't have to convert it into decimal degree notation and then back. I can keep it in DMS notation. So if I go into angle, I'm going to type 90 first, then go into angle. That is 90 degrees minus 28 angle degrees, 34 angle minutes. It should give me an answer back in DMS. Ooh, it didn't. That's okay. Angle, I'm going to convert that decimal degree measure into DMS, degrees, minutes, seconds. So angle H is 61 degrees, 26 minutes. Okay, cool. So now I know angle H in DMS notation to match angle G. I already knew F, of course, is 90, so I don't need to calculate it. That's a known. Now I need little f and little h. Okay, I can't use the Pythagorean Theorem since I only know one side, not two, so I'm going to have to use some trig identities here. So first, little h. I know angle G, and in terms of G, I have opposite and adjacent. That's going to be tangent. So I would start with saying that the tangent of 28 degrees, 34 minutes, is 17.3 divided by h. Okay? Now, if I multiply the h over, that will be h times the tangent. Then I can divide the tangent back over. So h times tangent of 28 degrees, 34 minutes equals 17.3. That means that h is going to be equal to 17.3 divided by the tangent of 28 degrees, 34 minutes. Okay? I'm going to do this in the calculator first, then on decimals, just for comparison. So that's 17.3 divided by the tangent of 28 angle degrees, 34 angle minutes, and I get an h value of 31.77. So that is our h. Okay, now I'm going to compare real quick, do this in decimals just to see how it looks a little different. Remember that we can't type DMS notation, so I could type in 17.3 divided by the tangent of, I would type this as 28 plus 34 divided by 60, because that's 34 divided by 60, because there are 60 minutes in a degree. And again, I do get the same answer of 31.77 for my side. Okay, so it does look different in the way I would type it if I was going to use decimals versus my calculator. Let's go back and find the side f. Now I have choices. From here I could just use the Pythagorean Theorem, but since I have this rounded value, let me go back and do some arc trig or trig so that I don't have to use the value that I have rounded here. I can use the exact values that I was given. Okay, so in terms of these two sides, this will be opposite and hypotenuse, so it's going to be sine. So we're going to have the sine of 28 degrees 34 minutes equals 17.3 divided by f. I'm going to multiply that f over, divide the sine over, so I will get that f is equal to 17.3 divided by the sine of 28 degrees 34 minutes. Okay. I already have something similar typed in my calculator, so if I go back up there, all I need to do is change that sine function, that tangent function from the previous one to the sine function, and I can hit enter on that. And so f is 36.17, actually 18. And I have all parts of my triangle solved for.